So I'm ZB. There's no slide about myself. If you type Naukter into any text field anywhere, if you find something, it's going to be about me. Let's proceed. So, yeah. If I gave you a string of text, do we know each other well enough that you would put it in your application and run it? No? No? I heard a no. Would it help if I wrapped it in a tar.gz? Because that's effectively what NPM packages are. Strings of text from random people wrapped in a tar.gz that come to you on a daily basis, and they're glorious. We all love them. And wouldn't it be great to keep consuming them indefinitely and not worry about it at all? I know I did, and I loved it, and then in 2015 I looked into supply chain security, and I still love it. So I started looking into supply chain security a while back, and there's a bunch of stuff I already talked about. This is not going to be about these things. So previously on supply chain security, I started with looking at audits. If anyone remembers Node Security Project, wave your hands. It was awesome. Yeah, yeah. I put that in CI, and my team hated me. So later on, I had to implement something called npm audit resolver, where we would manage, still in a secure way, our security culture on the team, and we could safely ignore things. That's very important. And I'm very close to releasing the next major version that would finally support latest NPM and latest yarns. So if anyone wants to help me push it through the last few steps, please. This is a hobby project. And then I went in and looked at malicious install scripts. You know, I wrote a post-install script that makes TypeScript compiler installed alongside, introduce Eval code to your code base while compiling. That was fun. And then you can protect yourself. With LavaMoat allow scripts, this problem's gone. And can I ignore scripts helps you decide which of them you need to run. And that's all available on my website. Check it out later. OK, going back to a random string that I'm giving you that you are supposed to run in your application. Yeah, let's generalize to just evaluating it. OK? And this is the meme you all came here to see, right? So with that out of the way, let's move on to discussing the dangers of running someone else's code. So I'm not going to focus on the obvious, but my favorite topic to discuss here is exfiltration. So someone can steal your stuff, which is if someone takes process.env and pipes that to fetch, would you enjoy it? I wouldn't. There's prototype pollution, so if some of your data is not available as easily as you know, process.env, someone can use prototype pollution to like change the map implementation on an array and steal the contents of any array you process, because why not? And then fetch to their server. They could introduce some code that takes any user input and just puts it in Eval, because why not, right? And you have another sink in your application for remote code execution that didn't have to go into NPM packages. Obviously, file system access. Yeah. And do you remember event stream? This is exactly what happens. Someone took over a package and introduced some malicious code, and it was super targeted. And it wasn't a post-install script. That's notable. OK, so yeah, that's not good. I hope I can still keep making this joke next year. Yeah. So let's look at means of isolating things from each other. If we take a package and we don't trust it, can we put it in a separate process? Like, you know, run the package in the Lambda function and communicate with it. It wouldn't be too reasonable, because inter-process communication requires a protocol. You would have to do, like, you know, an HTTP server to call a function from a package. No, that's too much. So let's dive into the process. Hello, we have threads, isolates, we have context or realms, mention Cloudflare workers. If you want to know what Cloudflare workers is, imagine a tab in a browser but on a server. Yeah, that's not helpful. And there's the VM module, which is not supposed to be used for any security. Yeah, there's not enough repeating that. So still, if we want to isolate, we put something in a different realm, then the problem is you call into a function of a package, and that package then takes the array you passed it and does instance of array, and it gets a false because it's not instance of array. Because the prototype for array is different in a different realm. It's the same exact prototype, but it has a different reference, and instance of is checking the reference. So goodbye interoperability between your NPM packages, right? So this is not the way to isolate packages. We want packages within one thread, one realm to live alongside each other and be isolated from each other so that they can hurt each other and hurt your own code. Meanwhile, they need to communicate. So one package is making a function call to another package, and this is perfectly normal, right? This happens all the time. You use it. So how do we approach that? Well, what if one of those packages turns malicious? We want it to not affect anything else. We want to keep consuming it, even if it's malicious. So a bit of background, I work at MetaMask. It's a wallet for crypto stuff. I don't get most of it, but I'm working on a security team that focuses on JavaScript supply chain security there. And if something pops up on an audit as a malicious script, it's already too late for us. If something makes an outbound request, like you heard a few talks back, and we detect that outbound request, it's too late already. So how do we prevent code that we already put in production from doing malicious stuff if we didn't notice it before? Well, time for a demo. You like demos? I like demos. Everyone likes demos. Yeah. Okay, so this is a simulation. So it's only a bit of code, and this is not clean. Okay, so I have a script that, oops, yeah, sorry, not this. Yay, I broke it. Okay, this is the starting point. No, this is not the starting point. This is the starting point. Okay, once again, thank you. Okay, so I have a tiny application. It just gets some input and then runs a package that's supposed to provide some functionality. The functionality is super simple here. It's just, adding a number to complete a meme. That's nice. And now it has some admin panel as well, so when you go into the admin panel, it's going to be visible. And this is a simulation of a package. So I had a package working. I'm evaluating it, right? And now I upgrade the package to version 2. And hello, now I'm an admin all of a sudden. Why? Because the version 2 is changing my global state. Well, that was pretty naive, but okay. So how do I prevent that from happening? How do I prevent a package from reaching out to my global scope? Well, I have a function to replace eval with, and it's called good. And the good function will let me decide what's the global scope. And come on, VS Code. Okay, so as you can see, the package still works. It provides value to my application, but it can no longer set is admin because it doesn't have access to the original global scope. It has access to a different global scope. Interesting, right? Okay, I have one more trick up my sleeve as an evil hacker. So the next version of the package is obfuscated so that you don't know what it is, and I can prove that this is not static analysis. And if you look at this comment, what it's actually doing is prototype pollution. So the state gets polluted with isAdmin, and since it doesn't have its own property isAdmin, it's going to reach through the prototype chain and find it. That's ugly, but we can prevent it. So I have another nice function, lockdown. And now the package still works, if you notice. It's 42, but it cannot add property is admin to the object prototype because it's no longer extensible. Thank you, goodbye. No hacking for you. Okay, how it works. This is the secret sauce, okay? So this is how it's currently implemented. It's just a shim, I'll get there. But we have a good function that accepts some source code and the global object, and it calls an evaluator on that. And the evaluator has a function with strict mode enabled inside, which runs eval on the code, right? So fairly similar, but there's a with statement in here. Have you seen with statement? Like, potentially the only time you saw with statement is in Douglas Crockford's book that says not to use it. Well, we did. So it's with is taking an object, taking its fields, and exploding them into the local scope. All right? So this is eval once. This is an object with the field called eval with a getter that only returns something once. Okay, so we run the eval, but then the code that we eval with eval doesn't have access to eval anymore. So it can't escape our confinement by just running out of scope. And then we have the scope guard, and this is the great part, where we take our new global object and we put it in a proxy. So whenever something requests the scope and it reaches the global object, it's going to take fields from it. But the proxy will say yes to any request for any name. So that means anything that you try to read from the global scope, the proxy will say, yes, I have it, and then return undefined. So no globals for you. Yeah, that's what it looks like. And then lockdown. This is a super simplified version of lockdown, but just for you to get the idea. So we freeze the intrinsics. This is what the built-in stuff in JavaScript is called, in spec. And I had to read some spec. Yeah, lovely. And then we also don't want more eval to happen, so we take the function constructor, which accepts the string and returns a function that if you call it would run that string, and we replace it. So we have a getter function that returns a function that ignores the input and returns a function that if you run it, you get an error. Okay, yeah, I didn't practice it. Okay, next. So the actual secure ECMAScript shim, SES for short, is a bit larger, mostly for the lockdown implementation and for the fact that you don't only have to protect the globals, you also have to virtualize the implementation of import, and that's a lot of work. But it's not that big, and look at the number of comments. It's not an anti-pattern in this case. I only had to learn a tiny bit of it to work on it, and building a mental model of what it does took about a month. But SES is a TC39 proposal. Round of applause for TC39, maybe? Yeah. Really, fingers crossed for it to pass quickly. And currently, a subset of SES in proposal compartments is being worked on. So there's going to be a module class that you can use to virtualize module loading and implement your own logic behind import. Using any source of random strings by random people. Isn't that great, potentially? Yeah, and eventually all of this gets into the language and there's no performance overhead for running securely, etc. Looks good. So now let's look at what it opens us up to. So there's this concept, and it's super old, but somehow it's not well known yet, of object capability as a security primitive, as opposed to identity-based security that we all know and struggle with. So identity-based security is when you type Node.js space app.js and run some code. That code runs on behalf of you in the operating system. So the code has all the permissions that you have. because of that identity. And then within our application, we are always struggling to figure out the identity of things and decide if they should have access to the file system or not, and how are we sure that the identity is not spoofed in any way. And object capability just gets rid of that problem by using programming primitives to pass authority around instead of locking it in certain places and figuring out by identity. So this is what it looks like. It's much simpler shown as code than the thing I blabbed about. So imagine you have a linter that instead of importing fs gets it as an argument. You can give it anything as fs. You want the linter to only check and not fix anything. You give them access to read file and nothing else, so it won't write to your disk because it doesn't have means to do it. And there's no looking up of identity. It's just a linter you run, and that's enough identity you need. You just pass it capability from the outside. And this process is called attenuation, the process of making the object that represents some powers lesser than the full scope of powers. So in this case, you can limit the paths that it could access, right? Okay, so secure ECMAScript, SAS, shim, and later compartments in the language is what makes object capability, all cap for short, work. So we have a compartment for scope isolation. We have lockdown function that turns JavaScript onto itself to block all the prototype pollution and ugliness you could do to destroy the local environment in malicious ways. And then we have a hardened function that does pretty much the same to the powerful objects that you want to give someone who you don't trust. Okay, so it looks like JavaScript is being designed in a way that makes it a very good language for this. Because take ECMA and W3C. They're two separate organizations. Add Conway's law, which we all know and love, and we get a specification or a bunch of specifications that make JavaScript be one thing and all the powerful objects available to it be a separate thing. So every power that you could abuse is either available through scope or through an import statement. There's no other way, well, almost, but there's pretty much no other way to get your hands on anything powerful other than that. And compartment controls scope, so how can I use it? This is, this is late in the talk, but I'm going to show you how this could be useful. So first off, you can use SAS compartment and lockdown directly to implement your own features where you get code from someone you don't trust, and you want to get the benefits of that code with no risks whatsoever. And I'm saying this lightly because SAS is coming from the same author that created use strict in the language, and it's been a long game. So use strict was and object freeze was introduced to the language to make SAS possible all those years later. And now on top of SAS, there's a bunch of things that were already built. So we're using SAS directly for MetaMask Snaps, which is a plugin system where we're giving a plugin access to some very private information, and it can only interact with our own API and nothing else in JavaScript, in the browser, and whatever. So it has no means to exfiltrate that information. And then there's endo, another anagram of node. So there's node, deno, endo. We're not done yet. Endo is going to be, because it's still a bit hard to use, but it's going to be a runtime that uses SAS behind the scenes to isolate everything from everything and be super secure. Just this year, I introduced support for CommonJS into that because it would be only imports initially. And then the last but not least is LavaMoat, which is the thing that we built at MetaMask, which is a convenience layer to use SAS for supply chain security. So LavaMoat is currently protecting the live installations of MetaMask for over 20 million users, and we introduced that and no one noticed. So it works. And I'm going to show you a usage example. And if you want a sticker with that image, I have plenty, enough for everyone. So come and grab it. There's some at the lobby as well. So yeah, not this. I still have a demo to do in 5 minutes. It should work. So there's a LavaMoat thingy. OK, we have an application. OK, we have an application, and the application is using a sample package that's gonna, yeah, one more zoom in, maybe. OK. That's gonna create a poem from a buffer of numbers using a bunch of mathematical expressions. So if I run it with Node, I get a poem. And now, the fun part of LavaMoat is that it can help you generate the entire policy. So this app is already installed with LavaMoat, so I have some scripts here, but you could run these as commands. So I'm going to do npm run policy. What this does is it generates a file called policy.json. And this is after your code and your dependencies were analyzed for whatever powers they're using. So we know that our package is using a global buffer and the from field of that buffer, and then depends on some packages, and these packages are using some built-ins and some built-ins and global. So BNJS is using buffer from 2 different sources simultaneously, because why not? And then the time comes to update the package. So I'm going to do a tiny update on the package here. I installed a new version of that package. And now if I run it with Node, bad things are going to happen. But I'm not going to run it with Node. I have this package in here that if I start it, it runs it through LavaMoat. So I can now run it through LavaMoat. I didn't demo running it through LavaMoat before, but trust me. OK, and boom. OK, so I got an error that says required node built-in package not in allow list. So Eval sample now requested HTTPS, and I didn't allow that. So the Eval sample internally looks something like this. So it does the poet thing, but also in version 1.0.1, it introduces all of this mess, which takes, where is it? It takes your GitHub token and sends it somewhere. But it got into my application, the application run, and it didn't happen because HTTPS was not allowed. And if I run my policy again, you can see the update to the policy that you would then review is going to say that Eval sample is now using a built-in HTTPS.request. So we can find it, but we're not depending on the static analysis. The static analysis didn't have to run or exist for this to be prevented based on the existing policy. So the static analysis is only used to help you generate the policy, and then you can override details of that policy manually to limit it or extend it as you need. But the protection is based on secure ECMAScript, which makes it literally impossible after a bunch of audits that happened to it. So I'm not concerned saying that. It makes it impossible for you to reach for powers that we didn't allow unless we accidentally give those powers to you by reference. And yes, that's pretty much it. And if you want more, there's 2 more things. First off, I'm going to help you set up LavaMoat for your project if you want to. Limited time offer. You can find me wherever Nauctor is a string of text that you put it somewhere. So nauctor.pl is my website on the QR code. And then there's Twitter. I have a newsletter that I am rebooting now, and I do some training, random stuff. And if you want more about secure ECMAScript, you can hear from Mark Miller himself. There's a link. The slides are already on my website, so you can go there, click the link. There's an hour of presentation about more of hardened JavaScript from Mark Miller, who's the original author, the person who came up with it. Okay, thank you.